The series in the example 10 should have looked familiar, and that is the geometric series. So remembering from Algebra 2, the geometric series, we have that in order for the geometric series to converge, the absolute value of r, which is the common ratio, must be less than 1. And then the series will converge to the first term over 1 minus r. If the magnitude of the ratio is greater than or equal to 1, the series diverges. So that means we want for the series to converge, r is going to be between 1 and negative 1. Now, when you're setting these up, this number in the parentheses is your r. So r equals 0.9, which means my absolute value of r is less than 1. I'll do that in a different color. So absolute value of r is less than 1. So therefore, the series converges by the geometric series test. Now we can find what it converges to. S is equal to my first term, which is, so a over 1 minus r. First term, plug in 1 for n, and we get 2 for 1 minus 0.9. So we have 2 over 1/10, which gives me that the series converges to 20. So let's look at this next one. Our r is equal to 3/2. The absolute value of r is greater than 1. Therefore, n equals 0 to infinity times 3/2 to the n diverges by geometric series. So I'd like you to work on the other two examples, and we will talk about those in class tomorrow. Okay, so geometric series are some of the simplest that we investigate, but others simplify quite nicely as well. Now, this is what's called a telescoping series, and you should recognize this as a partial fraction decomposition. So if we were to simplify this or combine this, you have 1 over n minus 1 over n plus 1, which means I would have n plus 1 minus n over n times n plus 1, which would give me 1 over n times n plus 1. So if you see a series like this, this is your clue that it's going to be partial fractions. We're going to use partial fraction decomposition to simplify it. And it will likely be a telescoping series. Now, what does a telescoping series mean? So let's go ahead and write out the first 3 partial sums. So our first sum is going to be 1 over 1 minus 1 over 2. Our second partial sum will be 1 minus 1/2, which is our initial thing, plus, Now we're going to plug in 2 for n. We have 1/2 minus 1/3. Our third partial sum gives us 1 minus 1/2 plus 1/2 minus 1/3. And switching this up again, plus 1/3 minus 1/4. So, what do you notice as you go along with these terms of the sequence? So, let me flip back to the page. Scroll down. You should notice that these interior terms are going to cancel. So we can write an nth term is going to be 1, and then this last term is minus 1 over n plus 1. The third term, our last term, is 1/4. The second term, our last term, is 1/3. The first term, our last term, is 1/2. So, I'll write this up here. So our interior terms cancel. Our S sub n is 1 minus 1 over n plus 1. So, limit as n goes to infinity. And we have 1 minus 1 over n plus 1. And that converges to 1. Therefore, this series converges to 1 by the telescoping series. Okay, so a telescoping series is one in which all interior terms cancel with another interior term somewhere else, leaving only the first and last terms. So we're going to write out the first two terms, and then I want you to figure out whether it converges or diverges. So S1 will give us 1/2 minus 1/3. S2 gives me 1/2 minus 1/3. Plus 1/3 minus 1/4. S sub 3 is 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5, which means S sub n, and I'm going to leave that one for you. Now, with this one, we have to use partial fractions. So we know that this is n equals 1 to infinity. It's going to be a over n plus b over n plus 2. Using partial fractions, we have 4 is equal to a times n plus 2 plus bn. So let n equal to 0, and we have 4 equals 2a, so a equals 2. And then we're going to let n equal negative 2, so 4 equals negative 2b, so b equals negative 2. So now we have from n equals 1 to infinity of 2 over n minus 2 over n plus 2. Now I'm not going to write these terms in the multicolors that I did in the previous one, but I think you can figure that out. So we have s sub 1 is going to be 2 minus 2/3, s sub 2, 2 minus 2/3, plus 1 minus 1/2, s sub 3, 2 minus 2/3, plus 1 minus 1/2, and we put in 3, so we have 2/3 minus 2/5, s sub 4, 2 minus 2/3, plus 1 minus 1/2, plus 2/3 minus 2/5, and we have 1/2 minus 1/3. Now I'm going to write the beginning here. So now let's look at the fourth partial sum. We have the 2/3 are going to cancel. I have a 1/2 that's going to cancel. So you end up with 2 plus 1 minus, and this is 2 over n plus 1, and then minus now 1/3 is, let me back up and I'm going to rewrite the 1/3, because let's actually do this. It's actually going to be, right? The 1/3 is actually 2/6. So using that term, this is 2 over n plus 2. So taking our limit as n goes to infinity, and if we carry this out enough, I take the limit as n goes to infinity of 2 plus 1 minus this 2 over n plus 1 would probably cancel, but it doesn't matter if it's in 2 over n plus 2. Well, that goes to 3, which means then, therefore, 4 over n squared plus 2n converges to 3 by the telescoping series test. So you may have to write out several partial sums in order to be able to find what the nth term is of that partial sum. So, interesting to note, geometric series and telescoping series are the only ones that we can find what the series will converge to. The remaining tests will be a test for convergence, but will not allow for an exact calculation. All right, so finish up the examples that we skipped, and we will go over these in class tomorrow. and you'll have plenty of time for practice.